doing?
Yes, I think I'm okay. Perfect. Yes, I'm ready.
Okay, so it's f of x equals 5 over x minus 4, and then g of x equals 5 over x
Plus 4? Yeah, I think that this is the problem we did in class, but maybe not. It was similar. It doesn't matter. So what are we asked to do?
You're find f of g of x and g of f.
So we are asked to show whether they are inverses of each other, or we are simply asked to find f cum g and g cum f.
Inverses.
So check if they are inverses of each other. Very good. So then I have to find f cum g. So I write f of g of x, which is the definition. I replace g of x by g of x by 5 over x plus 4. Very good. Equals. So now I look at f. What does f say? It says 5 over whatever you want minus 4. So can anyone dictate what to write next?
5 over 5 over x minus 1 minus 4.
And the whole thing minus 4. Oh, it's on the bottom.
But this is on the bottom, so that's where it goes, right? I can't change that. I have to follow the pattern. The pattern says 5 over whatever you want plus 4. Is that clear? Yes? Is that clear why it's in the denominator? Yes? So these two go away. The numerator is 5 over 1. The denominator is 5 over x. So I flip because I multiply and I get x. It's a very good practice to redo the problems we do in class first before you attempt anything. Is this okay? Yes? Okay. So I assume the other one will be too, but let's show. This is g of f of x, which is g of, and now what do I put? Yes? Very good. Awesome. So now let's look at g. G says 5 over whatever you have plus 4. Very good. And plus 4. Correct. Very good. Awesome. So 5 over 1 at the top divided by 5 over x minus 4 and plus 4. So far, so good? So then this is 5 over 1 times x minus 4 over 5 and plus 4. I simplify, and I get x minus 4 plus 4. It happens to be x. What do I conclude about f and g? Yes, because this is x and this is x, f and g are inverses of each other. Can anyone give us g inverse? Can anyone give us g inverse with no calculations whatsoever? Not negative, just this. If these are two are inverses of each other, this must be g inverse and this must be f inverse. So this is 5 over x minus 4. It must be. If they are inverses of each other, f is the inverse of g, so f can be denoted by g inverse, and g is the inverse of f, so g can be denoted by f inverse. Very good. Good question. Anything else? Does it make sense? Is that a yes or a no? Perfect. Next question. Anything else you have for me? Say it again.
So I have another one.
Yes.
I just need help with g of f of x.
Yes.
So it's the f of x is 5x minus 7, and then the g of x is x plus 5.
And we want to determine just g cum f?
I thought it was 5x minus 19 over 7. it's wrong.
So what do we need to calculate? G comp F?
Oh, 5x minus 24.
So we have F,
I don't know what
and we have G. But what is the question? Is this correct, 5x minus 7 for F? Is this correct, x plus 5 over 7 for G? So what are we calculating? You said G comp F or F comp G?
Is it ball or golf?
it's golf.
Okay, so let's find G comp F, which is G of F of X, which is G of G of
5x minus
perfect, thank you, right? Good, so now look at G. G says whatever plus 5 over 7. How do I write this?
5x minus 7 plus 1.
Very good. So this is 5x minus 2 over 7. Since it does not equal x, what do we conclude about F and G?
They're not.
Not inverses of each other. Very good. Are not inverses. I'm sorry?
I said I see them.
Okay. That's why we're here. Anything else? Is there anything else we worked on? Anything else we have questions on? Okay then, so the last section of this chapter is 2.8 and deals with three things. That 8 deals with the distance formula, deals with midpoint formula, and it deals with the equation of a circle. The first two are known, but I'll start from scratch. The last one should not be known. It will be new. Okay, so we are interested in determining the distance or the length of the segment connecting 2 points. So let's create 2 points, one here and one here. I'm going to call this point A and this point B. I'm going to denote the coordinates of A as x1 comma y1 because A is the first point. And the coordinates of B as, what do you think? Obviously, very good. Thank you. I am going to connect the 2 points, and we are trying to find We are trying to find a way to determine D. We will form a right triangle with a horizontal line passing through point A and a vertical line passing through point B that will create a 90-degree angle. And of course, I'm going to call this leg 1. I'm going to call this leg 2. So one leg is leg 1, the other leg is leg 2, and the distance or the hypotenuse is D. Can anyone tell us what is the Pythagorean theorem? What is the equation that I have to write with the given notation? Do not say a squared plus b squared equals c squared because that means nothing. Leg 1 squared, very good. Plus leg 2 squared, awesome.
Equals hypotenuse squared.
Excellent. That's all I needed. So this is what you have to remember it. The sum of the legs squared equals the hypotenuse squared. Because when you use A, B, and C, nobody knows which one is the leg, which one is the hypotenuse. So this is the correct Pythagorean theorem. Let me write this for you. Pythagorean theorem. Perfect. Now, is there a way of determining the first leg? So this is the x-coordinate of A. What is this? This is the x-coordinate of B. What is this? Perfect. So now can anyone give us the length of this leg?
X. x2 minus x1.
Correct. x2 minus x1 is this leg, the measure of leg 1. Is that clear? Perfect. So this is x2 minus x1. What do you think about this, which is the measure of the other leg? Of course, it must be y2 minus y1. So now please plug it in and tell me what to write. What do I replace leg 1 by? Very good. Obviously, x2 minus x1 squared and y2 minus y1 squared equals the distance squared. I don't really want the distance squared. I want the distance. What do I do to both sides to solve such an equation for d? Take the square root. Very good. When I take the square root from both sides, I have to remember a crucial thing, which is correct. In this particular case, I will not write plus or minus. And you can say, you are changing the rules on us. Not really. Why I will not write plus or minus in this case? Because it's a distance. It's a length. It cannot be a negative number, correct? So that's the only reason why. Okay, perfect. So then x2 minus x1, everything squared, plus y2 minus y1, everything squared. Can I further simplify this? Or this is it? This will be the distance formula. Can I further simplify it? Can I say it's the square root of the first quantity plus the square root of the second quantity? I'm glad you did not say that. So the answer is no. Very good. The square root of a squared plus b squared does not equal the square root of a squared plus the square root of b squared. Let me give an example. Let's say the square root of 4 plus 9. Does this equal the square root of 4 plus the square root of 9? The answer is no. The left-hand side is the square root of 13. The right-hand side is 2 plus 3. So they cannot be the same. So the distance formula is this, and no one can simplify that formula in any way, shape, or form. Now you understand that this will be always what type of number? Very good. This will always be what type of number? Perfect. And when we add two positive numbers? Correct. So I will never see on the next test or the final exam as the distance to be the square root of negative 47, correct? Perfect, right?
Right.
Good. Good, so we'll come back here. So right here in the middle of the distance, or there is a point right in the middle that bisects, divides the line segment or the length between A and B or the distance between A and B in two equal parts. That is called the midpoint, M. And the coordinates of the midpoint are, when we calculate an average of two numbers, what do we write? When we want to calculate the average of x and y, how do I calculate the average?
You add up and divide.
By their number. I add them up, so there are two numbers, and divide by their number. That's the average. So that's why it's easy to remember. x1 plus x2 over 2 will be the x coordinate. And what do you think the y coordinate will be?
Y1 minus y2.
Plus. The average means plus. Perfect. So give me 2 points so we can illustrate. So this is the midpoint. The midpoint formula. Or I wouldn't say formula, but just the midpoint. It's good enough. So can anyone give us two ordered pairs so we can calculate the distance and find the midpoint, the coordinates of the midpoint?
Five, 7.
Okay, also throw in some, let's say, -5 and 7.
Yeah. 3 and 6.
3 and 6. Perfect. Let's find the midpoint because it's right here, right now. Please add up the x's.
-2.
Perfect. And divide by 2. That's it. That's the x coordinate of the midpoint. Please add up the y's. Divide that by 2. So -1 comma 13/2 is nothing else but the midpoint. Okay? Now let's find the distance. We want to find the distance between these 2 points. So the distance, I write the formula first. x2 minus x1, everything squared, plus y2 minus y1, everything squared. I see the cell phone. And I will label them as x1, y1, and x2, y2. Any order you like. It doesn't matter. I will write them underneath so I don't have to write them again and write the distance formula again. It's up to you. You choose the method. But I prefer this. And I write x1, which is -5. And I write 6 for y2. And I write 7 for y1. I think it cuts back on writing a little bit, but you choose the method you like. So now the distance is the square root. Let's work on this together. 3 minus -5. What do I have inside parentheses? How much? 8. How much is 8 squared? Excellent. Now plus. How much is 6 minus 7? -1. How much is -1 squared? Perfect. So the distance is the square root of 65. That's it. So we can measure the distance between 2 points and get the square root of 65 in this case. Last topic of chapter 2 is the circle. So I'm going to attempt to graph a circle. I know it's not a lousy attempt, but that's all I can do. The center of the circle will be denoted by h comma k by convention. And what is this? Awesome. That is the radius, lowercase r. And I'm going to call this point A, any point on the circle, x comma y. If I write that the distance AC is the same with the radius, would you agree? Is the distance between A and C the same with the radius? Good. So now I would like you on the left-hand side to use the distance formula and write the distance AC. Very good. x2 minus x1, which is x minus h, everything squared, plus, awesome, y minus k, everything squared equals. Perfect. Thank you, William. Okay, so number 5, my page 5. Now, I don't really like, in this particular case, a square root in there. So what should I do to eliminate the square root? Yes, I'm going to square both sides, and I get x plus, oh, I'm sorry, I didn't mean to write plus. Please.
In the distance formula, is it x squared minus x1 squared, or is it just x2 minus x1?
So let's take a look. Very good question.
Because that one's squared.
Okay, so this leg is x2 minus x1. This leg is y2 minus y1. When I put this in the Pythagorean theorem, it has to be the first leg squared plus the second leg squared. The first leg is this, and it has to be squared. The second leg is this, and it has to be squared. So it's not x2 squared minus x1 squared. Yes. Is that better?
Yeah.
So now when we take the square root, we cannot take the square root from a sum. So that's why we keep the square root. But I can take the square root from this, and I get d. Better? I'm not sure I answered your question. Did I?
You did.
Okay. So then we have x minus h, everything squared, plus y minus k, everything squared equals? Awesome. This is the equation of a circle. with center h comma k and radius r. So this is the equation of the circle with center h comma k and radius r. Okay? There are 3 types of problems in this section for the circle. Okay, 3 types. Any questions for me? Yes.
I don't remember. So the first equation, the d AC equals r,
Yes?
and then it's the same thing as the square root of.
So I used the distance formula that we have here for this distance, denoting this by x2, y2, and this by x1, y1,
Yeah, so that's what I'm saying. It's the same as
the distance formula.
which is the one underneath it there.
Yes.
Okay.
So x minus h squared plus y minus k squared square root equals the radius.
Okay.
Better? And then we squared both sides. So we square the left and we square the right
Just to get
the equation of the circle.
Okay.
Better?
Mhm.
Other questions for me? Okay, we have 3 types of problems here. The first one is the easiest. On page 333, problem 36. On 332, forgive me. We are given a center, which is -3, 5, and the radius of 3. We're asked to find the equation and graph the circle. Can anyone give us an idea of what to do, how to get the equation of this circle with the center at -3, 5, and the radius of 3?
The radius is 3. You can add a 3 to, like, vertically 3 or horizontally 3.
When we graph it, but right now we want to find the equation. Amanda?
So h and k is the center, so you would put in -3 for h.
Exactly.
Okay.
Perfect. That's all I need. So I'm ready. Perfect. If you want, or anyone else.
X would be +3
Of course.
squared plus y minus 5 equals 3 squared.
Which is still 9. Perfect. Very good. This is it. This is the equation of the circle with center -3, 5, and the radius of 3. Now let's graph it. I start with the center, which is -3, 1, 2, 3, 1, 2, 3, 4, 5, right here. This is the center. And then I create 4 points, cardinal points, north, south, east, west. How many units away? From exactly how many units away from the center?
Oh, 3.
Perfect.
Where'd you get 9?
You have to square. This is r squared. So that's how we get the 9. So this is squared, this is squared, this is squared. So 3 squared is 9. Better? Everyone? Okay. So now I want 3 units away. 1, 2, 3. 1, 2, 3. My graph is not going to be perfect. 1, 2, 3. 1, 2, 3. Maybe this point is a little, I'm going to move it here. So here's the circle. Far from being perfect. My apologies. But I determined good 4 points. Now if I ask you, what is the range of the circle? Although is it a function? No, but even relations have a domain and range. So what is the domain and what is the range of this circle, please? 6, 0, awesome for the domain. Very good. And 2 plus 6, right? It has to be 2 plus 6. So 2, 8. Very good. Awesome. Second type of problem. Here is 46. On the same page, 332. Any questions? Stop me, please. In 46, we have x plus 1, everything squared, plus y minus 4, everything squared equals 25. Now I'm going to ask you, is this the equation of a circle?
No.
So let's analyze it by comparison, right? So first, let's go back in the equation of the circle and talk a little bit about it. What does it have? It has a completed square with x and a number. So x plus or minus, I don't care, a number, and everything is squared. Then there is a plus. Then there is a completed square with y and a number squared. And then equal symbol, and then a positive number. If this is 0, the circle is just a point. If this is negative, that's impossible, because I cannot have a positive number plus a positive number equal a negative number. So this must be a number greater than 0. So now let's look at what we have. Is this a completed square with x and a number, or just x? It can be just x. Yes. Is there a plus?
Yes.
Is this a completed square with y?
Yes.
Is this the equal symbol? Is this a positive number? Okay, let's try again. Is this the equation of a circle?
Yes.
Is that clear?
But don't you have the square root of that? It's not square root.
So the equation of the circle is a completed square with x squared plus a completed square with y equals a number that is positive. So all I'm asking is if this equation looks like this one. So it is the equation of a circle then. If I have minus here, or if I have a negative number here, or if I have power 3, or if I don't have a power at all, then I would say no. But this is exactly the same pattern. We agree? Okay, now here's the question in question type number 2. Find the center and find the radius. Let's start with the radius. What will be the radius of this circle? Awesome. So now let's look at what we have in parentheses, and keep in mind what happened over there. When age was -3, look what happened. And when k was positive, look what happened. So now I would like you to identify the center.
-1, 4.
That's it. So this is the equation of a circle. The center is -1, 4, and the radius is 5. Any questions? We agree? Awesome. The third type, I hope that you're going to like it. Let's take a look. Let's say problem 54. X squared plus y squared plus 8x plus 4y plus 16 equals 0. So now I'm asking you, is this the equation of a circle? Exactly. That's the correct answer. It may be. The correct answer is I have no idea. It may. Wait, I don't know. If I manage to rearrange it like this, then I'll say yes. If I cannot rearrange it like that, I'll say no. So compare these two and say, oh, I know what I have to do. And tell me what. Close. Let me repeat what I just said. What do I see here? So here's what I see. A completed square with x plus a completed square with y equals a positive number. So now I'm going to ask again.
Would it be x minus 8 squared?
What do we have to do to all this to make it look like that? I'm looking for a keyword that I already used. And it's a method that we solved quadratic equations with, and I said, oh, of course this is not for that. It's for something else at the end of chapter 2.
Is it completed square?
Thank you. That's what it is. It's a completed square. And another completed square. That's exactly it. That's why we studied completing the square when we solved quadratic equations. And I said, that's not for them, right? it alone cannot even solve the quadratic equation. It's for this. So then, in order to complete the square for x, please tell me what we need to add to both sides. Disregard the rest of the terms. Don't even look at anything. Exactly. Do you agree with 16? The middle coefficient divided by 2 is 4. 4 squared is 16. Agreed? Awesome. So we are adding 16 to both sides. However, hold on. Because I already have 16 here, I don't have to do this just for x. So I'm going to use it. So there is no need, only because this free term is already 16. If it were something else, I would have added 16 to both sides. So now these three terms are here. Where? Very good. So now let's look at the terms with y. So I have y squared and I have 4y. What do I need to add? And this time I have no choice. What do I need to add to both sides? Like we complete the square to solve the quadratic equation. The middle coefficient is 4. We divide it by 2. We get 2. And we square that number. So we get, very good. So now, plus, don't forget the plus. These three terms are here. Where? Exactly. There is no minus? Plus? Yes. If I write 4, 4 squared will be 16, and I don't have 16. Very good. And now, what is left? There is only one number left on the other side, which is 4. Now I'm asking myself again, or I'm going to ask you, is this the equation of a circle? Yes. It's a sum of two squares. One has x, the other one has y, and the free term or the radius is positive. Cannot be anything else. So now we're asked to identify the center and the radius. And then we'll work on one more problem. What is the center? Careful.
-4.
Very good. And the radius? 2. Do we want to graph another one, or we got the idea on I'm sorry?
Another one of that kind.
I'm sorry?
Another one of like that.
No. I mean, do we want to graph this one? Or, yes, we will choose another in a minute. But do we want to graph this one, or we know how to graph?
No, I graph.
You want to graph?
No, we know.
Okay, very good. So then let's choose another. 58. Same page. X squared plus y squared plus 12x minus 6y minus 4 equals 0. Is this the equation of the circle? Exactly. The answer is we have no clue. Wait, see if I can rearrange it. If I can't, it's not. In a particular form, of course. Okay, so disregard the rest of the terms and just tell me what you want to add to complete the square with x squared plus 12x. Exactly. 12 divided by 2 is 6. 6 squared is 36. Please remember, like we did with the quadratic equation, we have to add to both sides. If you only add to one side, you destroy the balance. You have to add to both sides. Very good. So now this and this and this, they're all here. Awesome. Then I have to have plus. There is no discussion there. So now let's look at y squared and negative 6y. And please tell me what we add to both sides. Do you all agree with 9? Yes? Because it's negative 6 divided by 2 is negative 3. Negative 3 squared is 9. Do you all agree? Okay, so now this term, and this term, all these three are here. Perfect. Thank you. I'm sorry? Say it again. I just didn't.
I thought it had to be a positive number.
Because it's negative 6. So when I complete the square and the middle term is negative, the answer has to be negative. Because when I expand this, I will get positive if I don't put negative in here, right?
Right.
Perfect. So now here's what is left. Careful. This is not accounted for, this is not accounted for, and this is not accounted for yet. These two numbers are already on the right-hand side. This one isn't yet. I have to move it to this side. It becomes 36 plus 4 is
40.
plus 9.
49.
See how useful this is now? I mean, we had no difficulties in completing the square because we learned this before. So I'm asking again, is this the equation of a circle? Perfect. I need the center then and the radius.
-6, 3,
Awesome.
and so radius is 7.
Excellent. Thank you, Daniel. Wonderful. This is it. We're done with chapter 2, finally. How long it took us? Like a month and a half? Okay. We start chapter 3. At the end of chapter 3, we will schedule our second test. So you have till Sunday this week to finish everything for test 1. I want to finish that and close it, and we move forward, right? So this coming Sunday, I have no idea what it is.
21st.
Thank you very much. Okay, finish everything in my math lab for test 1. I mean, if we don't finish this so we can move on, then we are really falling behind. So please finish everything by Sunday night. Is that okay? Is that okay?
Like the quizzes,
Everything. I don't want to talk about test 1 anymore. I'm kidding. You know what I mean. So the other thing that I am kindly, I don't mind begging you, please, every weekend, redo the test 1 and moving forward, all tests that we are going to have. Take an hour with your friend, with anybody you want, or alone, and redo. I posted solutions. They're posted. Print them out or not. Just save them in on your flash drive or phone, whatever you want, and redo the test till the end of the semester.
Because all that stuff's going to be on the file.
Exactly. And then 2 days before the final, nobody's going to, right? Go crazy because I have to review this. No, I only have to review this that is left over, maybe from test 3. We are going to review. I'm trying to use an entire week to review with you. But still, you'll be so much more ahead. You'll say, oh, I know this. I don't have to review it. So please do that. I'm begging you to do it. Put time aside every weekend. There are only 9 more weekends, or maybe 8, to tell you the truth, till the end of the semester. Okay, so please, chapter 3. We still have chapter 3, chapter 4, and systems and matrices. So there is still a lot of material. Okay, chapter 3 deals with polynomial and rational functions. So polynomial functions, remember it's a big group of functions. The first one and the easiest one is linear. No discussion there, it's done and super discussed and beat to the ground. Number 2, quadratic. This is what we're going to discuss in 3.1. We're going to refresh our memory, and you can say again, we already graphed it in transformations. What else do you want? Okay, we still have a lot to talk about. In 3, we are going to have higher degree polynomial functions, like degree 3, 4, 5, 6, and so on and so forth. And number 4, rational functions. And the last item from chapter 3, still a lot as I said, deals with inequalities that are not linear or absolute value, but polynomial and rational inequalities. This is what's ahead of us in chapter 3. And that's at the end of this, we're going to schedule test 2. So let's go back to quadratic. 3.1. We're going to graph, and we're going to look at some word problems, and then hopefully, if possible today, move on to 3.2, polynomial functions. Let's see if we can. Okay, a quadratic, so 3.1. Quadratic functions. Okay, they can be given to us in two different ways. They can be given to us as ax squared plus bx plus c, or as we saw in transformations, like this. And no, h and k do not have anything to do with the circle here. It happens that we use the same notation. We will discuss in a minute what this means. I'll come back to that, but I'd like to start with an example of this kind. So for example, let's say f of x equals x squared minus 6x plus 8. What type of function is this? Thank you. So we're asked to graph it. We're going to go through 7 steps, maybe even 8. The first one, domain. And this is true for any polynomial function. What is the domain of any polynomial function? Absolutely, always. So domain negative infinity to positive infinity. Number 2, shape. And you can say shape? Yes. A parabola, this is called a parabola. The graph of a quadratic function is called parabola. Can open upward or downward, upwards or downwards. This has a minimum. Obviously, this has a maximum. It's one or the other. So when it has a minimum, the leading coefficient, which is this number, this leading coefficient, is positive. When it has a maximum, the leading coefficient is negative. So I can identify the shape way before I graph the function. So let's find the leading coefficient for this function that we are looking at. What is it? The leading coefficient is 1. So which of the two shapes we will have to graph with a minimum? So the shape is this. Number 3. X-intercepts if they exist. So let's talk about this before we continue. I'll come back. Does the parabola that we are looking at right now, does it have a minimum or a maximum? Minimum. There are 3 possibilities for a minimum. Here is one possibility. Here is the second possibility. And here's the third one. What am I really telling you? In this case, do the x-intercepts exist? No. In this case, do the x-intercepts exist? Yes. It's still 2 solutions, but it's the same solution. Right? Quadratic function has, right? What about here? 2 solutions, but distinct solutions, not the same. Here, 2 solutions, but they are the same. Over there, no solutions, or we say imaginary solutions. And here, 2 solutions. Good. Before going into the x-intercepts, I would like to discuss one more point because it's easy. It's better to connect them than do the x-intercepts and then the other point. So forgive me, I'm going to put 3 here and this 4. Sorry about that. The vertex. I need to find the vertex. It's easier to connect 3 and 4 than 4 and then the other one. So what is the vertex? This is the vertex. In our case, the vertex will be a minimum. This is also called vertex. For that situation, it will be a maximum. How do I determine the vertex? The x-coordinate of the vertex is important. Easy to remember. Do you remember when we solve a quadratic equation by the quadratic formula? We have negative b, something follows over 2a, right? This is the x-coordinate of the vertex. Easy to remember. Just negative b over 2a. The rest is part of the quadratic formula, not part of the vertex. So let's determine negative b over 2a. So x equals negative b over 2a in our case is negative. How much is b? How much is 2 times a? 2 times 1, yes, is 2. So this is negative 6 over 2. So the answer is? But there are 2, yes. So, say it again.
No, just
So we determined the x-coordinate of the vertex, but now the question is, how do I find the y-coordinate? I have the function, I have the x, how do I determine the y?
like an X.
Exactly, of course. So this will be f of 3. So let's find f of 3. F of 3 is 9 minus 18 plus 8. How much is f of 3? So 3 squared is 9. Negative 6 times 3 is negative 18. And plus 8. 9 plus 8, 17 minus 18, negative 1. So the vertex has coordinates 3, negative 1. So now I want to discuss the x-intercepts.
Wait, how should we look at
Plugging 3.
that? Right.
3 squared is 9.
Oh, and then you add them all together and then you.
I have to, yes, that's how yes. So now the vertex will tell us which situation we're in. The vertex is 3, negative 1. This function has a minimum. What is its minimum value? Correct. The minimum value is negative 1. Is this a minimum value with a negative 1? No. Is this a minimum value with a negative 1? No. Do the x-intercepts exist? Do the x-intercepts exist? They are the same or they are distinct? Distinct. So I will spend the time to find them. Now, if you remember, the quadratic formula has plus or minus the square root of b squared minus 4ac. This is such an important quantity that we named it discriminant, if you remember. What is a discriminant in this case? Positive, negative, or 0? If it's positive, then I can take the square root and I have 2 distinct solutions. But because there are no solutions, b squared minus 4ac must be negative. They are imaginary solutions. So when the quadratic function does not touch or cross the x-axis, the discriminant must be negative because this number or these numbers are imaginary. What about here? What will b squared minus 4ac equal to? Say it again. So x equals negative b plus or minus the square root of a number divided by 2. This number, if this number is negative, you cannot take the square root from it. So then the solutions don't exist.
Is it 0?
Yes, it is 0. If it is 0, there is only one solution, negative b over 2a, which is also the x-coordinate of the vertex. So what about this situation? B squared minus 4ac, what type of number would that be? Definitely positive, because I will take the square root from it and determine two distinct real solutions. Is this clear, Amanda? Do you want me to repeat?
No, I think I got it.
So if this is a negative number, I will never be able to determine solutions, which must be this case. The function is way above the x-axis, does not touch the x-axis, there are no x-intercepts, because these numbers will be imaginary. Now, if this is 0, I only get one option, 2, but they are the same. I only get negative b over 2a, so this is the case. Now, if this is a positive number, I will be able to get two distinct solutions. One with plus in front, one with minus in front, and this is the square root of 4, which is 2. That's why it's this case. Okay, so the x-intercepts exist. How do I determine them? For any function.
In the distinct.
How do we determine the x-intercepts? For any function. What do I have to write?